Hello and welcome, ladies and gentlemen. By sequencing the genome of a person, one can deep dive into the nuances of one's genetic identity and gain better insights into health conditions. Yes, we are talking about genetic diagnostics that is empowering people to make informed health choices. And so, in this particular edition of Face to Face with BioVoice News, we have with us Mr. Mahesh Pratapneni, who is the co-founder and board member of MedGenome, India's leading genomics and clinical data-driven diagnostics and drug discovery research company. And today we will try to gain fresh insights on the growth of genomics in India and the potential it holds from Mahesh. A warm welcome to you, Mahesh, and thanks for joining us today.
Thank you. Good morning, and glad to be here so that we can convey some of the value of this new science and how it's impacting lives here.
So now, before we begin, I would like to share a few details about my guest, Mr. Mahesh Pratapneni today. So, apart from leading strategy, partnerships, and corporate development, including fundraising for MedGenome, Mahesh is also the founder and MD of Emerge Ventures that specializes in incubating product companies in the education, healthcare, and data analytics sectors. He's known for building outstanding global teams and comes with broad experience in product visualization, development, management, and building global delivery models. He holds a BTech degree in electronics and communications from IIT Madras and an MBA from IIM Calcutta. So without much ado, I'd like to begin this interview. So Mahesh, please enlighten us about the concept of genetic diagnostics and personal genomics, or what I should say, personalized healthcare.
So from a genetics point of view, there is as human beings, as all organisms evolved, a lot of our body's mechanisms is all encoded in our DNA, which is almost seems like magic even to scientists as we keep deciphering how uniform the DNA is between different organisms. So between a pig and a human being, 80% of the DNA is the same, but the differences are so telling. And all of the DNA is made out of just 4 different amino acids. And the sequence that they are in, the coding that happens leads to the body, any body creating proteins, which then leads to all bodily functions. So which is not short of magic that we are able to survive, evolve continuously based off of just an encoding. And this DNA is same across all the cells of a person. So as we evolve, as we live our life, there are 2 types of changes that happen to these strands. So the strands will, when a cell replicates, the DNA is supposed to replicate exactly, but it's a chemical process. So there are always mistakes, just as with any process. And these mistakes are called mutations, which then lead to certain proteins not being coded or coded wrongly, or which then leads to certain bodily functions not happening. There are 2 types of mutations. One, which get inherited from your parents, ancestors. And the second is, as we live our life, this replication leads to certain other mutations. So germline mutations and somatic mutations. The germline mutations is what leads to most of the inherited disorders. So in India, about 100 million people today live with rare diseases, and these are largely genetic in nature. Every year, 1 million kids are born with debilitating genetic diseases. And this happens because the parents, we have 2 copies of every gene. Let's say one parent has 1 copy defective, they will not get the disease. And the second parent also has the same gene defective. both are healthy, but then when they have children, there's a 1/4 chance that the child will have a disease. And these things happen more and more because of our religious, language, cultural practices in India. That small groups of people, caste system, they will marry within the bounds of the group, however the group is created, either geographically, language based, or caste based marriages. And some of the communities also have high level of consanguinity. They marry within the family. Earlier, maybe it was for keeping property safe, but now that has led to these practices. So that's when you'll have more individuals who have the same harmful mutation in one gene each. So when they marry, a higher chance of us getting these kind of diseases. So India, the way it evolved over the last 2,000, 3,000 years because of caste system, language, geographical barriers, we are a very diverse population. But at the same time, there are about 4,500 subpopulation groups, which are very, very uniform. And that is where these kind of diseases keep increasing. So that's one aspect. And then as we live our life, some of these somatic mutations that come, that lead to body tries to error correct and tries to remove harmful mutation based cells. But once in a while, a mutation escapes. And once it escapes, that becomes potentially cancer, because body's immune system and defenses cannot eliminate that mutation. So they then replicate willy-nilly, and there's a potential for cancer. So these diseases, both sides, can only be understood if we understand the genetic makeup of the individual person. And that is where genetic testing or personalized medicine comes into play. So one is if a person has a disease, then to understand what the disease is and how the prognosis of that disease will be, it can only be understood once you read the sequence in which their DNA is, and then you compare it to a healthy DNA, then you know the mutations. So it's 3 billion base pairs, the whole genome. So typically you look at the exome, which are the genes which encode proteins. And then when you compare, there'll be mutations. Typically when we do our clinical exomes, we will find 50,000 to 100,000 differences between a normal versus but they're all not pathogenic. Then we have to find that one mutation or two mutations which cause the disease. So that is what MedGenome excels at. When you sequence a whole genome, you get about 100 GB of data. And then from that, you need to get one mutation which leads to the disease. So that is on the inherited diseases. And similarly on oncology, you will sequence the tumor and you'll see what are the mutations. And that can then lead to saying what exactly is the medication that this person should get. And in case of cancer, the best defense is how early can you detect, and how appropriate medication can you give. So this will allow you to say that these mutations exist, and now drug discovery has become very much standardized in oncology, that a lot of drugs will work only if there's a certain number of genetic mutations or certain types of genetic mutations. So we can recommend that these drugs exist and they will work best for you if you have lung cancer with these mutations. So that's the power of the personalized, or if not personalized, it is at least customized to the disease, targeting the disease. And both of these things couldn't be done until even 10 years ago. The genome itself was mapped 20 years ago, and then the cost of sequencing was very high. First genome took about $3 billion to sequence. Then there's been a rapid reduction. So when MedGenome started, one of the key things was this, that it had gotten to about $10,000 per whole genome. So this is in the 2010, 2011 timeframe. And now, of course, it's at $500 for whole genome, and will soon next year be about $200. So that leads to the affordability, and MedGenome has been working on bringing this to the masses. In just sequencing is not enough. Then you need to have the algorithms to identify what are the mutations. Then you need to have the biology aware scientist who will say this mutation with what research does it correlate. Then doctors who are aware. So all of this process is what leads to the benefits.
So, what are the awareness levels among the common people about these new technologies? How aware they are?
Common people are not that aware until maybe I'll segment that into three phases. So before 2013 odd, sorry, the awareness was very, very low. There's a company in US called the Myriad Genetics. They had found a gene called BRCA1, BRCA2, BRCA1, BRCA2. And that led to if someone had those mutations, it would lead to breast cancer with very high probability, 80-90%. And they were doing that test. In India, that was the first test that came, but awareness was very low. Then certain high-profile celebrities proactively started doing the tests and did mastectomy, and that Angelina Jolie was a famous case. So that brought some awareness because they were very vocal about the risks and how they are acting on it. Then the second big thing I would say is COVID. So COVID brought RNA, DNA, sequencing, these terms into common people's parlance. Because the virus had to be sequenced, it was mutating fast. Even the fact that there are versions of organisms, mutations happen. So there's some awareness of that. But the value of that beyond infectious diseases into human health is nascent. It's coming along slowly. And the big potential will be when people become aware of risk profiling. So the same genetic information, I was talking mostly about diagnostics. There's a disease, we tell you what's the reason. Then about 2018, new technologies emerged called polygenic risk score. So you can sequence few points in the genome and say whether you have a high risk of getting cardiac disease when you turn 35, 40 years old. And now we have tests which can say whether BMI will increase, the weight will increase. We have tests for diabetes risks. And I think by next year, we will have about tests in 12 areas: cancer risk, how does medication work for you, statins, do you need to take less statins, more statins, so the bleeding risk is not there. All of those are more consumer genomics. So like you were asking, and in those cases, having awareness is very important. Similarly, there are screening tests for birthing. Like I was saying, one gene has a harmful mutation, and for the husband and the wife, they should do something called carrier screening. So you are a carrier of that disease. So if you screen, then you will know that there's a risk that your child might have this disease. And these tests are a lot more valuable than doing a Janampatri, right? Where before you get married, better to do these kind of things. And it doesn't preclude a couple from having kids. There are so many assisted mechanisms these days, which are well accepted, not that expensive. Rather than having a child come into this world with a debilitating disease, and then the mother will family, everything is in deep trouble for many years, and the child had no hand in doing that. So that's another screening test. And then similarly, once the mother is pregnant, now there's just there are these tests called non-invasive prenatal testing. You can just take a blood sample, so no amniocentesis, no risk to the fetus. Just a blood test of the mother can say there are Down syndrome, many diseases are there or not, so you can screen. So this screening level of tests, I think the educated people in India at least should universally start doing. And we are trying our best. When we started out in 2011, 12, that time frame, even the doctors were not aware. So we did constantly did CMEs, continuing medical education programs. Every week we would do 2, 3, and we continue to do that. So now clinicians are very aware. The end users are not as aware.
Right, right. So how is MedGenome, enabling healthcare to be more intelligent and convenient through genetic diagnostics? And what are your key products and services, which are offered by you in India?
Yeah, so we do 3 areas where we are very big, and the fourth area, which is nascent. So, from a diagnostics point of view, we do diagnostics for the reproductive health, so carrier screening, NIPT, pre-implantation genetic screening in case of IVF. So we can say whether the embryo has defects, etc. And that's the reproductive segment. Then the second segment is inherited diseases. Like I was saying, there's a large burden of inherited diseases in India. So typically they bring, parents will bring, a family would bring the child to us at the age of 1, 2, or 3 when they're planning a second child. So unfortunately, you can't do too much for this child, but at least they become aware and the prognosis and how will the disease progression be. Then the third area is oncology, where a lot of progress has happened in the last 3 to 5 years. This is where targeted therapies have come. So we can tell very much for lung cancer, no clinician will start therapy without doing a genetic test. So targeted understanding of the tumor profile, and also a recommendation for what medication works, what therapy works. And the next area along the around the time of COVID we had started was infectious diseases. So we are the first company to have a sequencing-based, sputum sequencing-based test for drug-resistant tuberculosis. So we can take the sputum as is, sequence it right away, no culture required, and we can say exactly what type of bacteria, what organism is there. So again, targeted therapy, what concoction of antibiotics will work against this. So it's a little bit more expensive than the mass market tests, but it's coming along, and we're working on many ways to bring the cost down. But no other test available in case there is drug-resistant TB. So this is what you have to do.
So there's no competition to this drug. I mean, this particular
test. Yeah. So all the tests that we have developed are all done in-house, other than one test, the NIPT, which we license. So we have a test menu of about 500 tests. All of them are owned by us. In some cases, there are competing tests available in the market. This one is very completely unique. We have high resolution HLA typing. We have many tests which are proprietary completely. Then a new thing that is coming out is liquid biopsy. So we have launched, so let's say someone has cancer, just by, instead of doing a biopsy, and it's very difficult to do a biopsy of a lung, repeated biopsy has a risk of lung collapse, things like that. So you can just do a blood test once the person is on a certain medication, and then you can say whether the disease is retreating or remission, or is it coming back? Do you need to fine tune the therapies, or do you need to restart the person? So this is early surveillance, and also knowing whether the drug is working currently. So we have tests for MRD. We have now we are working on predictive liquid biopsy also. So these are the areas that we work in. The big value is one, these are not replacement tests. So the path lab test, the biochemistry test could never tell anything about these diseases. So we are the ones who created the market, the awareness, and we brought it to a price point where it's reasonably affordable. I wouldn't say it's at the 500,000. It's still average test costs in the range of 10,000 rupees. But it is accessible to a large number of population. When we started out, we had started these tests in 80,000 rupees range. But for MedGenome being there, international players will charge 5 to 8 times more than what we charge. In fact, for oncology tests, for whatever we charge, 15,000 rupees or 14,000 rupees, competitor, if you send it abroad to US, it'll cost 1.5 lakh rupees to 3 lakh rupees. So that's the thing. We keep driving it down. So one was awareness, then we created accessibility and affordability. So for accessibility, we made sure that we can collect samples in tier 2 towns. We can collect samples in many tier 3 towns also. And we are on a journey. So we still have more work to do.
Right. So, tell us about the company's recently launched personal genomics initiative under the brand name GeneSense. I mean, how do we make sense out of this particular product? I mean, what is it all about?
So one of the categories that I mentioned were largely about diagnostic. There is a disease, we tell you what disease is there and what treatment path to take. But like I was saying, the new science came for polygenic risk score. So this is where it is a person doesn't have a disease yet, but they have a propensity for the disease, and in many cases, very high propensity. So what we do is that we will sequence or we will read 600,000 to 800,000 points on a genome. Then, based on that, we extrapolate that using our algorithms and the databases that we have of Indian population to 6.5 million to 7 million points. Then we run them through algorithms which can categorize this people on a normalized curve. About 10 to 15% of the people have very 3x to 4x the risk of the regular population of getting either cardiac disease or diabetes, or they're on the other end of the spectrum for how drugs work on them. Now we are working on breast cancer risk. Soon there'll be the propensity for better athletic performance, propensity for getting your ligaments injured. These are all tests that are more screening and consumer friendly. And all of these tests are once in a lifetime tests. So if you do, let's say the cardiac, we have a test called cardiogen. So you do the genetic test for that. We put you in a high risk category. Then you do your lipid profile. If the lipid profile, typically one would say that if the glyceride, the total of triglycerides and HDL, LDL is about 200, you are in, you have to take care. But if you're in high risk category, you have to take care even at 150. And you calibrate that. You live a healthier life. Even more important for you to live a healthier life. So that doesn't mean that if you're not in the high risk category, you're normal, that you go crazy. But this category of people can even get on proactively get on intervention, working with clinicians. And we have been working with clinicians who have endorsed these tests. So that's the GeneSense tests, which are to be done in wellness. The previous tests were done in illness. So these tests, if you do it once, you have that data, and then you calibrate your lifestyle, so you have a healthier, longer, healthier life.
Right. So, in the post-COVID world, we have seen the cases of heart attacks, are increasing day by day.
Yeah.
So, will this particular test help in diagnosing? I mean, if anybody is having higher triglyceride levels or maybe higher cholesterol, which is at the alarming levels, so will this particular test help in diagnosing, the probability of heart attack earlier, much of?
Yeah, so this test will risk profile them. So it won't diagnose. So that's why I'm trying to differentiate between diagnostics is when you know 100% this is what is going to happen. But this one will say with 90%, 80% probability, if you have higher lipid profile, you are at severe risk of 3 times, 10 times more risk of getting a heart cardiac disease. And that's very valuable, right? Because people have been very lethargic. People have also, we see the spike in tuberculosis rates. We see a spike in late stage cancer because they didn't do the diagnostics early on, and they were because of the lockdowns and various reasons. So this will clearly risk profile a family or in an individual, saying that, hey, you are at a high risk. So when you do your lipid profile, if it is borderline normal or little bit higher than normal, it doesn't have to be significantly higher, you better intervene to bring it down. And it's of big value because it's a one-time test in life. So you always have the baseline. So then you can calibrate your and we will do the lipid profile and we will do the genetic test, and we can tell you a risk score based on both of them.
Right. Right. So there's a growing onus on drug discovery research because the kind of diseases unaddressed, areas we have in India. So how can the combination of big data and other digital tools help accelerate drug discovery research?
Yeah, that's a good question. That's so worldwide, there has been a big movement towards genomics informed drug discovery. What do I mean by genomics informed drug discovery? Is that FDA will say at various points. So, initially, understanding the mechanism, the reason a disease comes itself, genomics is needed. So, if this mutation is there and this mutation is there, and there are very interesting cases. There's a gene called PCSK9. There are certain mutations in that. Then these individuals did not have high cholesterol. Similarly, there are genes which lead to pain medication. There are a lot of genetic diseases, and also rare diseases are an extreme manifestation in a way of lifestyle diseases. So you can also understand a lot about lifestyle diseases by studying rare diseases. So just in the discovery itself, drug discovery, this mutation, what shall I do to plug that mutation or the proteins that come out of it or the biological activities that happen? How do we stop that? Second is when the drug development is happening, again, they use genomics for, if it's a biologic drug, they use genomics for developing the molecule and fine-tuning the molecule by using many genetic technologies. Then in clinical trials, if a drug has been developed in a targeted way, this drug works on a certain genetic profile, then FDA, which is the US authority for approval of drugs, will fast track a drug. So it will say that instead of doing clinical trials on 500,000 people, you can do it on 50 people. And because the science is known and then the impact is known, we will approve the drug. And many drugs have been approved like that for with even lesser than, especially in oncology, drugs get approved targeted like that. So that part is, again, how do you do patient selection so that the drug clinical trial is done only on the right genetic profile patients. So those are the three areas in which genomics has been involved in drug discovery. And whenever I say genomics, it's all based on data. Finally, 100 GB of data comes, and then you try to keep finding the right mutations in that and correlating that to the biological activity that is going on. So I think there's a recent paper which says that I think 70 to 80% of the new drugs in the last few years are genomics informed in one way or other, either one of the segments. And that's become the norm, and it will only keep improving because this also, from a pharma company point of view, this reduces the cost of drug discovery. In US especially, the cost of one successful drug is about 1.6 billion to 1.8 billion. By taking these methodologies, you can bring that down by 20-30% and also bring the drug faster to the market. When the drug comes faster to the market, then they have the ability to win against competition. So that's been happening worldwide. Now, for India, I think India is always a little behind in novel drug discovery because we have much bigger problems in other places. So we have taken the route of doing generics and biosimilars so that a large part of our population gets access to those well-proven drugs at least. So that said, now a new set of companies have come, which are, for example, Biocon is pursuing novel drugs in certain cancers. We know of this company called Immunil, which has come up with CAR T therapies, all homegrown, India-based. So India as a whole, just as the innovation cycle is moving, we get a lot of requests from Dr. Reddy's and all the local pharma to work with them in their drug development journeys. So many of them are biosimilars, but they're also working on novel drugs now, which are targeted Indian populations.
Right. So, Mahesh, I'll move on to my next question, which is related to which you just mentioned about the partnerships. So are there any partnerships which MedGenome is doing with any national or international organizations, both in academia as well as industry? And what is the nature of such collaboration?
Yeah. So in the US, MedGenome's business is largely focused on assisting pharma companies and academia with drug discovery efforts. Exactly what I was explaining. So we will plug in into the early stage. We will find a cohort of rare disease patients. So someone has, let's say, early onset Parkinson's disease. So we can create a set of, let's say, 300 people with all the clinical manifestation data and the genetic profiling. Then we do the analysis along with a pharma company in the US to identify which mutations are causal or at least correlated. Then together we work to see if they are causal, and then drug discovery progresses from there. Similarly, we work with many, practically all the top academic institutions in the US, Stanford, Johns Hopkins, Harvard, who's who, to work with their scientists in doing bioinformatics work, where we will analyze the genetic data. We will sequence some rare samples of diseases, work on that data to identify what could be mutations of interest. So we do a lot of work of that kind in the US. We have, as we do our diagnostics in India, we find many rare cases where we can see what mutations are there, but there is no research or no science available today which says that mutation leads to an XYZ disease. So those cases, some cases we do proactive work. We work with other pharma companies saying, hey, these cases are there. Can we look into that and see if there's any potential for drug discovery here? So lots of we work with some of the companies are there on our website. We have worked with Genentech, Pfizer, Gilead, Denali, a large number of companies in the US doing this. In India, we work with a lot of academic institutions. We have a lot of partnerships for diagnostics itself in India. AIMS, all the large government hospitals, we will work with them for doing genetic screening. And there are really mission-driven doctors who are focused on research, targeting diseases which are more frequently occurring in India. So we will do joint projects with them. Sometimes we do it at lower costs. We sometimes do like retinoblastoma. We do even sequencing for free. So we try to do our bit so that the Indian disease also gets some attention.
Right, right. So going forward, company has company put forward any major CapEx spending plans for, let's say, 2023, 24, or do you plan to expand in terms of infrastructure, services, or even resources?
Yeah, we recently did a funding round from Novo Holdings. So most of the fundraise is earmarked towards one kind of capex or other. So there are 2-3 things we are doing. We continue to do newer tests. So like I said, liquid biopsy, where you can do just take a blood sample and find whether a disease, cancer is going to come, or when you're in therapy, cancer is the drug is working, and then whether when you're in remission, is the disease coming back. So tests like that, which are very, very useful, and there are no alternatives for them, for patients and families. So we keep adding these kind of tests, and I think there's a portfolio of 500 tests we have now, and we will keep growing that in a very methodical way. Then new technologies keep coming. So we were doing only DNA sequencing, RNA sequencing. Now new technologies which have come are single cell sequencing, which will become diagnostics. Then we also have spatial genomics coming up. So there will be investment in using these core science improvements to build new tests. That's one. Number two, we have a lot of data, and that data, because we have done some 600,000 odd genetic tests, so we know what mutation causes what disease. And we have algorithms which every test that we have has a pipeline, which is an algorithm to figure out what is the mutation that causes that disease. So we are creating new AI ML modules so that a lot of that gets automated. So which leads to more accuracy, which leads to efficiencies of economies of scale, and bring the cost down, make the test go faster, and pass that all on to the patients so that we can bring the test prices down. So that's some capital investment. Then sequencing technologies keep moving forward. So we will have some investments for increasing our sequencing capacity because we do more and more tests. So right, this year we'll do about 250,000 tests. Next year we think we should put so proportionate increase in that. And then we are also looking at some inorganic opportunities just to make our tests available to a larger population, not just in India, but also in other emerging markets, Africa, Southeast Asia.
So right now you're pan-India, or you're more focused towards the southern region?
No, for genetic tests, we are the pan-India player. We are ahead of anyone else. But from a presence point of view, we are more present in South India. And some of it was because of the healthcare, right? More quaternary care, tertiary care hospitals were in South India. That has changed now over the last 10 years.
Right. So any plans to have your infrastructure offices in northern India, or let's say in western part, or
Yeah, we already do. So we have a lab now open in Delhi, which is very close to AIMS. And we have a lab in Mumbai, and we have a lab in Hyderabad. We have a lab in Cochin. But what we do in these locations depends on the sample volume and the local needs. So we'll be growing that selectively.
Right. So what do you consider as your key achievements, let's say, since inception, and where do you see the company in next 5 years?
I think one of the now this sounds like somewhat tooting our own horn, but MedGenome is the reason there is genetic testing available in India. When we started out, even the clinicians would look at us, hey, why would I prescribe a 50,000 rupee test? From that to now, on a daily basis, we do more than 1,000 tests. Is a journey which has been worthwhile and very satisfying, because each of those samples is a family which was groping for answers, and there was no way to get these answers other than the top 1%, which could send the samples abroad and pay 3 lakh rupees per test. There was no way to do this. So our big achievement would be keeping those three things moving together: awareness, making it accessible to all people, and then affordable so a larger set of the population can do it. Then the other, which is a more meta point, is that Indian ecosystem, whether from security, software, healthcare especially, it doesn't lend itself to innovative companies. India generally does efficiency innovation. Nothing wrong with it, but we were focused on that. So like our software services companies have killed it in efficiency improvement. But core innovation has been very tough. So which is where MedGenome, I think, is maybe even now a unique company which did core innovation out of here. We built out the tests, we built out the sequencing, we created all the algorithms ourselves. There are a few companies which have come up now, MolBio, for doing TB tests. There are a few companies, like I said, which are doing novel biologics discovery. So I'm hoping this becomes a story and a norm that we can do core innovation out of India. So that's a very satisfying journey for us.
And MedGenome has been recently bestowed with the Excellence in Business Award, at the prestigious Global FTFIC Transformational Business Awards 2022. So what are your thoughts on that?
Yeah, we are very, very pleased and thankful that thankful that we have been selected. This is a global award for creating impact. IFC is the is the investment slash financial arm of World Bank, global organization. Similarly, FT is the top two newspapers, business newspapers in the world. So they did an evaluation on few parameters by saying who has brought core science or the business that any kind of business which creates impact and brought it to the masses, and a global competition where we got multiple awards, and also we got the overall win for being a transformational business. So very, very satisfied with that, very, very happy. And I'm hoping that can lead to us partnering with companies and organizations in Africa, Middle East, where again, similar character population and earnings characteristics as India are there. People still are paying $1,500, $2,000 for doing these tests, which we provide for $200. So I hope that's a launch pad for us to get into these markets.
So thank you, Mahesh. I really enjoyed this conversation today, and I'm hopeful that all our audience will also enjoy this conversation. Thank you so much for joining.
Thank you very much for talking to us and trying to make our journey visible to others.
Thank you, audience, and please stay tuned for our next episode of Face to Face with BioVoice. Thank you for joining us. Thank you.
Thank you.